Hello class. In this short video we're going to be looking at the properties of water, and considering over 60% of our body mass is made up of water, we should look at this very important molecule. So it all stems from the fact that we have polar covalent bonds in the water molecule between the hydrogen and oxygen. And when we have polar covalent bonds and the angular shape of water, we're going to have a partially positive side and a partially negative side, hence the molecular polarity or dipole as a whole. Now this will cause water to have hydrogen bonds between other molecules of water. And so the hydrogen bonding, because of the polarity of water, will give water very, very unique properties. On page 19 of your textbook, you have a very detailed chart, and this chart goes through all the properties of water and a brief explanation and why it's so important to learn in a biology class. So make sure you reference this page when you do your homework or complete the lab next class. So I'm going to go through all the properties of water, again, hopefully giving you a little visual as we go along. So cohesion is the tendency of water to stick together. In other words, water has a very good ability to cling to each other, and that will cause a high surface tension. And we will look at some examples in biology. For example, a water strider. The water strider has the ability to walk on water, and very, very few insects and animals are able to do this. It does so because the high surface tension of water, and it's because the appendages cannot penetrate this invisible film. We have this almost like this invisible film of that is allowing things to float. For example, we have this paper clip that is floating on the surface of the water. It cannot penetrate it. Going back to the water strider, another reason is there are very, very microscopic hairs all over the body, and these microscopic hairs are actually non-polar. So remember, non-polar substances do not dissolve or interact well with polar molecules like water, and so the water molecules will exclude the water strider hairs, and that will keep the water strider from penetrating that surface as well. So here's a look at the atomic or molecular scale. Essentially, we have this kind of invisible surface here, and we have these water molecules at the surface being pulled down and to the sides because they cling together very well due to hydrogen bonding, but we also have the force of gravity pulling it down as well, and that will cause there to be kind of this tough layer. Obviously it's not that tough, but it is this layer that will not be broken very easily. So we get this dome effect like so when we drop water say on a coin or on a non-polar surface here, etc. Now, adhesion. Water has a very good ability to cling to other substances. So notice the concave meniscus for water, and again it's because water clings to the sides of the test tube or graduated cylinder. In fact, we know from grade 9 and 10 that we read the meniscus from its very bottom, right, if it's a graduated cylinder. However, for substances, other substances, for example mercury, notice the convex meniscus kind of upside down from what we see. This is because mercury does not adhere very well to glass, but it is very cohesive, and it clings together more than it does other substances. But we won't be seeing this too often because we know mercury is very toxic and probably shouldn't be in an open test tube anyways. Here is an example of why cohesion and adhesion is so important. In trees, we can have water from the root system over here, going all the way up the xylem in the trees, the vessels themselves, and it can reach the leaves very, very high up in the top portion. So again, this occurs because of cohesion. The water molecules will tend to stick together and go up the xylem. Adhesion, because it will adhere to the xylem walls and creep up. So again, capillary action. Another property of water is the high heat capacity, or high specific heat capacity. So water has a very good ability to absorb large amounts of heat without changing its temperature very much. Or in other words, water requires a lot of energy for it to change its temperature. So it has a very good moderating effect if we have a large body of water near land. In the summertime, it's absorbing a lot of heat, but it doesn't really change the whole temperature of the lake itself. That's why it could be 40 degrees Celsius outside, but the lake that you swim in is probably a lot cooler. So that will provide kind of cooler air and this moderating effect in the summertime. And in the wintertime, you might notice that there is a little bit of a warmer air near the large body of water because, again, it's releasing amounts of heat, and it doesn't release it all at once, but essentially in the wintertime it could cause there to be warmer air, so hence the moderating effects. And this will occur in the human body as well. High heat of vaporization. So this is due to the many hydrogen bonds that must be broken to have sweat, which is essentially made up of water and other solutes. But here's the sweat, and as it's on the skin, when it evaporates, it actually will cool the body. This is how it works. So your sweat gland, due to maybe working out, will cause sweat to go onto the skin, and essentially the skin gives heat or transfers heat to the sweat, to the water. And the water, again, will absorb the heat from the skin so that it absorbs into the gas up here. So again, it will remove the heat or absorb heat, and then the skin and the person will get cooler, hence evaporative cooling. The last property that we're going to be looking at is the fact that solid ice is less dense than liquid water. And this is contrary to the trend of solid substances being greater density than the liquid counterpart. So it's due to the highest density of water at 4 degrees Celsius, so that's above the freezing point. So take a look at water when it's in ice form. Ice. This is liquid. They're closer together, hence in this area, or volume, it's more dense. Here, the water molecules have actually gone farther apart. When it freezes, it has a very special lattice, and it's actually expanded. And so we have less density. Hence the ice cube will float. However, and of course this is very important because, say, in a lake, the top freezes, but we still have fish and other aquatic life at the bottom enjoying the winter months. We don't want the whole lake to freeze up. The ice is just at the top. And of course, pond skating and pond hockey is important as well. Frozen water. So here is ice again, and here's the liquid water. However, on the right-hand side, we actually have frozen benzene. And notice this is what should happen. The solid is more dense, so it should sink. The liquid is less dense, surrounding it. However, water has that unusual property. So all of this is because of the polarity of water and its hydrogen bonding. So that's the end of this short lesson on properties of water, and now you'll be ready to complete the lab next class. Bye-bye.